Dear students, in this session we are going to see mainly about redox reactions, that too based on oxidation number. For example, potassium permanganate, acidified potassium permanganate is a best oxidizing agent. You may be knowing when KMnO4 with acid, that is acidified KMnO4. It is a best oxidizing agent. It oxidizes ferrous sulfate into ferric sulfate. During that process, potassium becomes potassium sulfate, manganese becomes manganese sulfate, and hydrogen becomes water. So that ferrous sulfate becomes ferric sulfate. We say it is oxidation of ferrous sulfate into ferric sulfate. But whenever we say about oxidation, reduction is also involved. That's why we say redox reaction. In terms of oxidation number, how do we say that it is a redox reaction? In this reaction, I said ferrous sulfate is oxidized to ferric. How? Sulfate minus 2 oxidation state. So ferrous, definitely it should be plus 2. Alright. Here it is ferric. Why? 2 Fe and 3 sulfate. 3 into sulfate, 2 minus becomes 6 minus. To compensate this, we have 2 Fe3. Therefore, oxidation state for iron is plus 3. So, iron from plus 2 oxidation state is oxidized to Fe3 plus. We say it is oxidation. Iron is oxidized. Oxidation of iron. So, definitely, one more element should be reduced. What is that? Sulfate is always sulfate. There is no change in the oxidation number for sulfate. Alright, always minus 2 on the whole. Hydrogen, always plus 1. We didn't get any metal hydrogen like that. Therefore, oxidation number for hydrogen minus 1. Likewise, oxygen, of course, except sulfate, minus 2. Sulfate also minus 2 only. Here also minus 2. There is no change in oxidation number for oxygen. Because we didn't get any peroxide, superoxide or with fluorine. We didn't get any peculiar oxide, a common thing. Therefore, oxidation number is minus 2. Potassium being alkali metal, oxidation state plus 1. Here also plus 1. Therefore, where is the change? Potassium, oxygen, hydrogen, sulfur, oxygen, everything same except iron. Iron from plus 1, oxidation 2. Likewise, it is manganese. It is manganese. Its oxidation number gets changed. How? Potassium, oxidation number plus 1. For manganese, we may not be knowing the oxidation number, let it be X. We have 4 oxygen atoms. For each oxygen atom, the oxidation state is minus 2. If we sum up, it will give the total charge on the molecule potassium permanganate 0. The sum of the oxidation number of different atoms present in the molecule should be equal to 0 if it is a neutral molecule. If it is ion, the charge on the ion. Here 1 potassium, charge plus 1. 1 manganese, 1 into X, simply X. We may not be knowing the oxidation state. 4 into minus 2. So plus 1 plus X minus 8 is equal to 0. X minus 7 is equal to 0. That means X is equal to plus 7. Here oxidation state of manganese is plus 7. Very important element, very important metal. Here the sulfate is minus 2 on the whole, including sulfur and oxygen. Therefore, definitely manganese should be plus 2. Important. Here manganese from plus 7 oxidation state is reduced to plus 2. Gain of 5 electrons. Gain of 5 electrons by manganese. Loss of 1 electron by iron from plus 2 to plus 3. Loss of 1 electron minus 1 E. So that is oxidation, here it is reduction. Addition of electron is reduction. Removal of electron, oxidation. And oxidation and reduction should go hand in hand. Of course, we can balance the equation. How? 2 potassium atoms we have, therefore 2 KMnO4 molecules. 2Mn, therefore 2MnSO4. 8 oxygen, all the oxygen should go as water, therefore 8H2O. 8H2, therefore 8H2SO4. Now we have to balance iron and sulfate. What about the number of sulfate ions here? 8, except for a sulfate. What about the number of sulfate ions except for sulfate? 3. It is 8, it is 3. 8 in the reactant side, 3 in the product side, 5. We have to add 5 in excess, and therefore put 5 here. Put 5 here. 5 into 3, 15. Here we need, yes, 10 iron, therefore 10. That's all. 10 iron, 10 iron. Sulfate 5 we have added. How? 5 into 3, 15. Here only 10. If you count the sulfate, 8 plus 10, 18. Here 10, 15 plus 2, 17 plus 1, 18. Balanced equation. Now, using oxidation number method, it can be balanced. That we are going to discuss earlier. I have taken ordinary method to balance. Using oxidation number method, we can balance. That we shall see little bit later. Before we go into balancing equations using oxidation number method, we are going to see the different types of redox reactions. All right? Different kinds of redox reactions we are going to see. What are the different kinds of redox reactions? One, combination reaction. Combination reaction. So combination reaction may be of redox type. We say it is combination reaction. It's a very simple combination. When carbon is burnt with air, it becomes carbon dioxide. It is a combination reaction. Combination of carbon and oxygen to give carbon dioxide. What about the oxidation state of carbon? 0. Why 0? All the elements in the elemental state 0. What about oxygen? Diatomic element, oxidation state 0. In elemental state, oxidation state should be 0. For oxygen, always -2. Of course, except peroxide, superoxide, etc. Here -2. 2 into -2, -4. Total charge -4. I mentioned total charge. Only for oxygen means +2. Sorry, -2. Oxidation state for oxygen is -2. What about for carbon? Let the oxidation state for carbon is equal to X plus 2 into -2 should be equal to 0. Carbon dioxide is made of 1 carbon, X, we considered X, 2 oxygen, 2 into -1 is equal to 0. Therefore, X minus 4 is equal to 0, X is equal to +4. So, oxidation state of carbon is +4. What has happened in the combination reaction? Carbon from from 0 oxidation state is oxidized to +4. How? By losing 4 electrons. By losing 4 electrons, the oxidation state of carbon from 0 is converted to +4. What about oxygen then? From 0 oxidation state is reduced to -2 by the gain of 2 electrons. By the gain of 2 electrons. One carbon atom loses 4 electrons. 2 into 2 electrons. Again totally 4 electrons. It is said to be a redox reaction of combination type. Here carbon and oxygen get combined to form carbon dioxide. At the same time, both the elements underwent redox reaction. One is oxidized, another one is reduced, and therefore it is said to be a redox reaction of combination type. All right. Then next reaction, decomposition. Just the reverse, maybe the reverse. But of course, carbon dioxide cannot become carbon and oxygen. We have to take some other example where decomposition reaction is involved in a redox reaction. Redox reaction resulting in decomposition. So, decomposition reaction. Second kind is decomposition reaction. First kind we have seen combination. Second kind decomposition. Here a compound potassium chlorate may be assumed to get decomposed when heated. Potassium chlorate when heated decomposes to form potassium chloride and oxygen. Of course, in the earlier example we have taken 2 elements to get combined to form a compound. Here a compound get decomposed into another compound and another element. All right. Now, for potassium, neither oxidation nor reduction, because its oxidation state is always +1, and therefore it need not be taken into account. All right, I can rub. What about chlorine? Chlorine. Here the oxidation state of chlorine we can very well find out -1, +1, -1. Then only the total charge will be 0. So chlorine is in -1. What about oxygen here? In the elemental state, oxidation state should be 0. In the elemental state, oxidation state should be 0. Here oxygen is in -2 oxidation state, potassium +1. What may be the oxidation state for chlorine? Usually halogens -1. Fluorine is always -1, but other halogens may have different oxidation state. Even positive oxidation state is also possible for chlorine. Here what is the oxidation state for chlorine? Here in other compound, normal compound, it is -1 only. Therefore we made -1. But here potassium +1, chlorine, we don't know, let it be X. 3 oxygen, 3 into -2 is equal to 0. So X -5 +1 -6, total -5 is equal to 0. X is equal to +5. All right. So chlorine from +5 oxidation state is reduced to -1. How? By gain of 6 electrons. It has gained 6 electrons. Oxygen from -2 oxidation state is oxidized to 0. Its oxidation number get increased. It lost 2 electrons. Each oxygen is losing 2 electrons. 3 oxygen, therefore 3 into electron, totally -6. Therefore, equal number of electrons are gained and lost. It is a decomposition reaction of redox type. Oxidation, here oxidation because loss of electron. Here reduction because gain of electron. So in any reaction involving oxidation and reduction simultaneously, we call redox reaction. And since it involves decomposition of a compound, we call it as decomposition reaction. All right. Then let me go into the next type, displacement reaction. Third type, displacement reaction. One can displace the other. Third one, displacement reaction. What is displacement reaction? So under redox reaction, we are studying types of redox reactions. All right. Types of redox reactions. So third type, displacement. First one, combination. First one we have seen combination. Second one, decomposition. Third one, displacement. Now we are seeing displacement. What is displacement? When a metal is placed into some other substance, solution of some other substance, it can displace the metal. We call it as metal displacement. Metal displacement. Metal displacement reaction. One metal can displace another one. For example, when zinc rod is dipped into copper sulfate solution. See, copper sulfate is a solution. We may be knowing copper is reddish brown in color, but copper sulfate, hydrated copper sulfate is blue, and copper sulfate solution is also blue. Copper sulfate solution is blue in color. All right. The solution happens to be blue. It is blue in color. All right. Now, when a rod, say zinc rod is dipped into that. Zinc rod is colorless, maybe bluish white we can say. It's zinc rod. What is happening? The zinc started to displace copper from copper sulfate solution. In copper sulfate solution, copper is in the form of Cu2 plus sulfate SO4 2 minus. Zinc metal, zero oxidation state. Why zero? Elemental state. As long as a metal or element is in the elementary condition, oxidation state 0. Here, copper plus 2. What is happening? When zinc displaces copper from copper sulfate solution, it started to gain electron, and therefore copper is becoming copper metal and zinc is becoming zinc sulfate. Zinc, by losing 2 electrons, become Zn2 plus. Copper, by gaining 2 electrons, become copper element. So gain of electron. It gains 2 electrons. It loses 2 electrons. So it is oxidized and it is reduced. Zinc is getting oxidized. So compared to copper, zinc can easily lose electron. Therefore it is losing. The blue color disappears because it becomes zinc sulfate. It is colorless. When copper is deposited, it is become reddish brown. It is brown. It is becoming reddish brown because of deposition of copper. After some time, earlier it was zinc. Earlier it was zinc with blue colored solution. Now it has become a colorless solution with the deposition of copper. Deposition of copper here. All right. So copper from +2 oxidation state is converted into 0 oxidation state. This is metal displacement involving redox reaction. Copper metal is being displaced. All right. Then displacement of non-metal is also possible. Non-metal displacement. In non-metal displacement, when zinc is placed in hydrochloric acid solution, zinc displaces hydrogen. It becomes zinc chloride. Just like here, it becomes zinc sulfate. Now it becomes zinc chloride. Hydrogen is displaced. It is a non-metal. Elemental hydrogen has got 2 atoms of hydrogen, therefore H2. So how to balance 2 hydrogen, therefore 2. That's all. Zinc from 0 oxidation state is oxidized to +2, just here, like here. Hydrogen from 0 oxidation state, +1. +1 hydrogen, chlorine, mostly -1. Since chlorine is -1, it is +1. Hydrogen from +1 oxidation state is converted to 0 oxidation state because in the elemental condition. As long as it is in elemental condition, it is 0. It loses 1 electron, gains 1 electron to become 0 oxidation state. +1 plus -1. Electron is -1. Zinc loses 2 electrons to become +2. -2 electrons. Here we have 2 hydrogen. Each hydrogen loses 1 electron to become H2. Since chlorine is -1, 2 into -1 -2, it should be +2. That you may be knowing. So metal displacement as well as non-metal displacement. In both these reactions, redox reaction has happened. Oxidation as well as reduction took place simultaneously. Therefore, we say displacement reaction involving redox. Then next type, displacement, and then disproportionation reaction. Next one, disproportionation. What is disproportionation reaction? One displacing the other. Autoredox. Autoredox reaction. Within itself, therefore we say disproportionation or autoredox reaction. When hydrogen peroxide get decomposed, or when chlorine is made to react with potassium hydroxide, in both the cases autoredox type or disproportionation reaction takes place. When hydrogen peroxide is decomposed, it gives hydrogen, water and oxygen. It is disproportionation. Why? From the same molecule, one element is getting oxidized and the same element is getting reduced. If the same element is getting oxidized as well as reduced, we say it is autoredox reaction or disproportionation reaction. How it is happening? Let us see. Hydrogen peroxide water and oxygen. How to balance the equation? It should be in even number, therefore 2. 2H2, therefore 2. I think it is balanced equation. Now, what about oxygen in hydrogen peroxide? In peroxides, oxidation number of oxygen need not be -2. It is different. How? Hydrogen plus 1. Hydrogen plus 1. We have 2 hydrogen, 2 into plus 1. Plus, we have 2 oxygen, 2 into X. We may not be knowing the oxidation state of oxygen here. But the sum should be 0. Sum of the oxidation number of all the atoms present in a molecule, neutron molecule, should be 0. Therefore, 2 into plus 1 plus 2x is equal to 0. 2x is equal to -2. Therefore, x is equal to -2 by 2, which is equal to -1. Oxidation number of oxygen is found to be -1 here. Don't forget it is -1. But in all the compounds except peroxide, superoxide, and then with the fluorine, they show oxidation state of -2. Obviously, 2 hydrogen, 2 into plus 1 plus 2, it should be -2 only. Here -2, here 0. How can it be 0? In the elemental condition, as long as we say an element, iron, cobalt, nickel, copper, oxygen, nitrogen, chlorine, any element, oxidation number should be 0. So here, oxygen from -1 is reduced to -2 by gain of an electron. Oxygen from -2 is oxidized to 0 by loss of 1 electron. Here gain of 1 electron, here loss of 1 electron. So here reduction, oxidation. It is said to be disproportionation or auto-redox reaction happening with the same element, oxidation as well as reduction. When chlorine is made to react with potassium hydroxide, it forms potassium chloride, potassium chlorate and water. Potassium chloride, potassium chlorate and water. How to balance the equation? We need at least 4 oxygen. Therefore, at least 4. If it is 4, 2H2O. 2H2O means oxygen becomes 5. So, it cannot be balanced. Oxygen should be in even number. It should be next to even number 6, therefore 3. Here 6. Alright. So, almost we have balanced the equation except potassium and chlorine. Here we have 6 potassium, therefore 5 KCl. If I disturb here, I cannot balance. 5 KCl. Totally 6 chlorine, therefore 3 Cl2. Now, where is the oxidation or reduction? Oxygen always -2, -2, -2, -2. In all its compounds, peroxide, superoxide, or else with the fluorine, likewise it may differ. Hydrogen +1 always, +1, +1. Potassium alkali metal +1, +1, +1. Where the difference? Chlorine. As long as it is in the form of element, oxidation state should be 0. Oxidation number of chlorine is 0. What about here? Here we have to find out how. Potassium +1, chlorine, we don't know X. Oxygen 3 into -2 is equal to 0. Sum of the oxidation state of all the atoms in the molecule should be 0. Therefore, +1 plus X minus 6 is equal to 0. X is equal to +5. Oxidation state of chlorine is +5 here. What about oxidation state of chlorine? Here -1. It is a chloride. +1, therefore -1. Here chlorine from 0 oxidation state is reduced to -1 by gain of 1 electron. Here chlorine from 0 oxidation state is oxidized to +5 by loss of 5 electrons. So, oxidation, reduction, simultaneously we call disproportionation. One is oxidized, another one is reduced. Same element. So, auto-redox reaction we say. Finally, competitive electron transfer. Competitive electron transfer. So, fourth method, disproportionation. Competitive electron transfer. What do you mean by competitive electron transfer? See, earlier we were discussing In displacement reaction, we have seen two types, metal displacement, non-metal displacement. In metal displacement, what we have seen, the reaction between zinc and copper sulfate to give Z copper and zinc sulfate. Copper is deposited. Copper from +2 oxidation state is converted to 0. But zinc from 0 is converted to +2. Zinc is oxidized. Zinc can readily lose 2 electrons to become +2 oxidation state. But on the other hand, the same copper, when allowed to react with silver nitrate, displaces copper. The reverse is not true. Suppose if copper is made to react with zinc sulfate, it is not possible. This conversion is not possible. Zinc and copper sulfate. This is not possible. This reaction will not happen. But copper can displace silver, so that you will be getting cupric nitrate. Usual valency of copper is +2 and silver is so +1 to 0. Copper 0 to +2. Cupric nitrate, nitrate -1. -1, 2 nitrates -2, therefore it is +2. Here, copper is oxidized to +2. That means it lost 2 electrons. So in the competitive electron transfer, what we say, in this competition, zinc is leading because it can displace copper from copper sulfate. Next to that, copper can in turn displace silver from silver sulfate, silver nitrate. Whereas the reverse is not true. Silver cannot displace copper from cupric nitrate, and copper cannot displace zinc from zinc sulfate. And therefore, in this competition or in this race, zinc can displace other metal. Therefore, it can readily lose electron. In terms of the tendency to lose electron, we can say zinc is much more better than copper, and copper in turn much more better than silver. And this reaction we say competitive electron transfer. So fifth type, competitive electron transfer. So these are the different type of redox reactions. In all these oxidation and reduction took place simultaneously. It is reduced by gain of 2 electrons. In all these reactions, silver is reduced from +1 to 0 by gain of 1 electron. So in all these reactions, redox reaction took place. Combination can be combination, decomposition, displacement metal or element, disproportionation where a particular element is getting oxidation reduced. Here in competitive electron transfer, one is superior over other in gain of electron or loss of electron. Here in terms of loss of electron, this is the order, and that is about different types of reactions involving oxidation and reduction. And in the next session, we'll be seeing how to balance equations by using oxidation number method. For that, you should practice you have to practice the calculation of oxidation number. All right. Thank you very much. Go and revise again and again. You'll be getting success. Thank you.